Hello to all of you. This is Dr. Dhaval Maheta, and today we will understand how to do the reliability and validity testing in Smart PLS. Basically, today we will talk about testing the measurement model. So, in my previous video, I have already discussed that what do I mean by outer model, inner model, and what are the parameters which are to be tested for it. Say, for example, consider this as to be your home. So, the outer model is the outer wall of our four walls of your home. So we do the reliability and validity testing of the outer model, which is also known as a measurement model. Once the reliability and validity is established, then you can move into the inner model, which is also known as a structural model. Now, the statistics, or rather, the things which you will measure for the structural model are path coefficients and R square. Consider this yellow boxes as your furniture. You can reorganize your furniture in whatever way you want. That is the inner model, you can reorganize it. But it can be only done when your reliability and validity of the model is established. Now, what is this whole concept of reliability and validity? Let us understand. We are having scales. Scales are available to measure weight, height, and temperature. But we don't have any scales to measure attitudes, beliefs, perceptions, opinions, and feelings. So we want to construct our own scale. For example, we can very easily measure the temperature of a person. But if we want to measure the temperament of a person, I require some formal question. Now, the reliability is a synonym. It's synonymous with consistency. Basically, it is degree to which an assessment tool produces a stable and consistent result. Let me try to explain this in a very simple example. Reliability is, are we getting same result using same instrument every time or not? It means that just try to recall our football team. I'll request all my viewers to refer my previous video so that you can understand the flow of this series. The same football team, if I repeat, will I be able to reproduce the same result? If yes, then my team is reliable. Similarly, when I repeat the survey, will it give me the same results? If it gives me the same result, then my instrument is reliable. So, we very well know that the loyalty was captured with the help of four statements S1, S2, S3, S4. Now, if this same instrument is repeated and we reproduce the same result, then we can say that my instrument is reliable. Validity refers to the degree to which an instrument accurately measures what it intends to measure. It means that if you have made a questionnaire for temperament, I will not be in the position to capture any other construct. So, is my instrument for a temperament able to capture the information which is necessary or not? Now here, validity can be again bifurcated into the convergent validity and the divergent validity. Convergent validity means how closely items of same construct are closely related with each other. Very simple. S1, S2, S3, S4 are the statements belonging to the same construct. This means that we expect a high degree of correlation or a cohesiveness among these statements. It is just like the team players which we had used for the football team. These team players should be having a high cohesiveness so that the team can perform better. Similarly, here also S1, S2, S3, S4 should have a high degree of correlation among them. Divergent validity means how closely items of different construct are closely related with each other. It means that there should be a weak correlation among the measured variables of different construct. I'll explain it in a simple way. We require a good degree of correlation among statements of loyalty. We require a good degree of correlation among the statements of satisfaction. So, but we require a less degree of correlation among the statements of loyalty with the statements of satisfaction. So, I can say this is desirable, but this is not desirable. So, we have to check the convergent validity as well as the divergent validity. Now, how will we check? the reliability of any construct. So S1, S2, S3, S4 are the statements which have captured the loyalty. Now, the more explanatory power of S1 is there on loyalty, it means that it will be able to extract more and more variance. So the performance of S1 is measured by the variance extracted by it. Similarly, S2, S3, and S4. Now, say for example, if we keep the threshold limit as 50% variance extracted, why we are keeping 50%? Because if any statement is able to explain less than 50%, we will not include that statement in our model or in our construct, because the nature's probability is 50% and this statement is able to explain less than 50%. Why should we include such statement in our construct? So 50% variance extracted, if I take the square root of it, it will give me 0.708. It means that for every path coefficient should have the path coefficient value should be more than 0.708, then only it will be able to explain more than 50%. Now, what is overall variance extracted, or also known as the average variance extracted? So if we say variance extracted of S1 plus variance extracted of S2 plus variance extracted of S3 plus variance extracted of S4, and its average is the average variance extracted of the construct. This also we want it to be more than 50%. The assessment of the reflective model includes the composite reliability to evaluate the internal consistency, individual indicator reliability, and average variance extracted to evaluate the convergent validity. If I talk about discriminant validity, we are using the Fornell-Larcker Criterion and Heterotrait-Monotrait Ratio. So if I talk about reliability, you can see first two are talking about the reliability and last two are talking about the validity. In case of first one, the indicator reliability, the item loading should be more than 0.708. This we have already discussed the reason for it. Composite reliability and Cronbach alpha, its value should be more than 0.70. Rho should be more than 0.0. So when I get both of them more than 0.0, it is I have achieved the internal consistent reliability. The convergent validity is that when overall AV, if it is more than 0.5, then the convergent validity is achieved. For divergent validity, we are seeing two, you can say two measures. One is a Fornell-Larcker criterion, in which we see the diagonal elements, and the another is a Heterotrait-Monotrait ratio. So here we require the value should be this value should be less than 0.85. Now all these threshold limits are given in the book, A Primer on Partial Least Square Structural Equation Modeling, written by Hare, Professor Hare, Professor Ringel, Professor Sarstedt. Now how to generate these results, let's see in SmartPLS. We have already discussed in my previous video how to generate the model. Once the model is generated, you will go in Calculate and you will click on PLS-SEM algorithm. Remember one thing, if you want to generate the statistics for the outer model, for the measurement model, you will go in PLS-SEM algorithm. If you want to generate the statistics related to the inner model, structural model, you will activate the bootstrap. I again repeat, if you want to generate the statistics which are related to the outer model, measurement model, you will go in PLS-SEM algorithm. If you want to generate the statistics which are related to the inner model, structural model, you will activate the bootstrap. So I'll go in PLS-SEM algorithm. Make sure that the path coefficient is on. Now, in the new SmartPLS, you can get the result. You can get the standardized estimates, unstandardized estimates, and mean center. And you can also change the initial weight for from here. Now you can activate start the calculation. Basically, R square is used whenever we activate the path coefficient. It will have an objective of maximizing the R square of the model. Now we will go here in open report. And here we'll activate, first of all, we will see the outer loading matrix, and you can see the results here. Now, when you will go in outer loadings matrix, you can see here all those statements which are indicated by green. If you take the square of this, okay, it will be more than 0.5. We have already explained the reason for it. If you recall here, the path coefficient should be more than 0.708, because if you take the square of it, minimum 50% should be extracted. So all this, as they are in green, the software itself will suggest that the average variance extracted is more than 50%. But when I see OC1, it is in red. It means that if you take the square of it, 0.67, it will be less than 50%. Now the question arises, what should I do when I get any of the variable whose variance extracted is less than 50%? So it is just like what to do if any team player is underperforming, right? Or any statement is not able to explain more than 50%. What should I do? So there is a method which has been given for deleting the statement in this book. First of all, check the outer loading relevance testing. If outer loading is less than 0.5, delete the reflective indicator. If outer loading is more than 0.5 but less than 0.7, analyze the impact of indicator deletion on AV and composite reliability. If outer loading is more than 0.7, retain the reflective indicator. But if it is between this, then deletion increases the measure above the threshold or not, that we will have to check. If it does, then delete the reflective indicator. If it does not, then retain the reflective indicator. The same thing I have tried to explain in my own words. Let us see. First of all, check the outer loading. Is it green? If it is green, and if your average variance extracted, the composite reliability, Cronbach alpha, rho, they are all green, then reliability and validity is achieved, right? From where I will get this reliability and validity? Okay, I will go in SmartPLS and I will click here on construct reliability and validity. So you can see everything is green here, right? Okay, let us go back in our flowchart. Now, if outer loading is red, so this is our case, second case. If everything is green, you will definitely you will not delete the variable and reliability and validity is achieved. But if outer loading is red, so in our case, one variable was in red, check the overall AV, CR, Cronbach alpha and rho. If it is green, don't delete the variable. So you have we have seen here that in case of our model, one of them was having less than, OC1 was having less than value less than 0.708, and therefore the variance extracted was less. Okay. But when we calculated the construct reliability and validity, all of them are green, so nothing to worry. Now we will take a case which is already given in SmartPLS, the sample data file. Before we run another sample, let me show you how in other ways you can report this result. When you click on Cronbach alpha, you will get the charts. You can copy this chart and you can take on the Word file directly. You can click on row, composite reliability, average variance extracted. Now in this SmartPLS version, you can also customize these charts. You click on it and you can customize the charts. Okay. You don't need to worry about the threshold limit, because you can see here the dotted line is given. This is the threshold limit. 0.7 is a threshold limit which is there. C for row, C for composite reliability. Now let us run one sample file which is there, which is given in SmartPLS. Press this edit, yes, and you will come on the home page again. Now there is one model which is European Customer Satisfaction Index, ECSI. You install it and the example will be loaded here. Click on PLS model and the model will appear. So here customer expectation is there, image is there, which is affecting customer satisfaction, perceived value. Now I want to see the reliability and validity of the outer model, the measurement model. So where should I go? Okay, I'll go and calculate. Any guesses? What should I click for measurement model? Yes, you are right. I'll click on PLS-SEM algorithm to evaluate the measurement model. So I'll click here. Make sure that the path is on, weighing scheme path is on, because we want to maximize the R square. Start the calculation and then press on open report. The first thing which you should do is go on outer loading and metrics. Now you can see here all those statements which are in green. Their variance extracted is more than 50% if you take the square of it. But those which are in red, say for example, Kusal 2, 0.202, if you take the square of it, it is hardly 40%. And therefore, this statement does not have the explanatory power, or the variance extracted is very, very less, or we can say that this is one of the team player which is underperforming. Now the question arises, should we delete it or not? So according to the authors of this book and the developers of this program, they have got a definite procedure. The first thing which you should see is that first of all, go in outer weights. Just a minute. Before clicking on outer weights or outer loading, just first of all see the model also. You can see here that the explanatory power of Kusal 2, let's try to locate here. It is very, very less, 0.202. The first thing which you should do is check the reliability. If everything is green here, no need to worry. So Kusal 2, no. The things are red here, and therefore this is problematic. So what is a procedure which has been recommended? Check the outer loading. If it is red, yes, Kusal 2 was having red 0.20. Check AV, CR, Cronbach, alpha and rho. If it is green, no need to worry, but that is also red. So now what I will do, delete the variable with lowest loading, delete one by one. Okay, so first pick up the statement which is having the lowest loading. So now you will go in the model and you will delete Kusal 2. Now you will again try to run this model, calculate PLS-SEM algorithm, start the calculation. Open the report and see the outer loadings. Is everything green in Kusal? Yes, everything is green in Kusal. Now I will also check the construct reliability and validity. Is everything in Kusal turned green? Fine. So what is the procedure? If by deleting the variable, if AVCR alpha rho turns green, delete the variable. Okay. So here the things are turning green and therefore Kusal 2 has to be deleted. Now let us go back on in our model and try to see about Q6. Q6 is having something in red, and let us try to locate which statement is having a less explanatory power. So I'll go in outer loading, click on matrix Q6. So 2 and 3, they are having very less explanatory power, 0.691 and 0.608, they are in red. If you feel that you are not able to see, you can maximize from here. So first of all, according to the authors, we will delete the statement which is underperforming, or we will delete the player, or we will remove the player which is not performing well. So 0.608, I will delete Q6 3. So I'll go again in the model and try to find out Q6 3, delete. Again, I'll try to run PLS-SEM algorithm, start the calculation. Now my expectation is that after running this, my AVCR should turn green. Let me check. Q6. No, it has not turned green. Still, it's red. Now, what to do in such scenario? So, even after deleting the variable, your AVCR alpha row are still red. There is a problem in the data, or there is a problem of outlier, or there is a problem of unengaged respondent. Now, what is this problem? Let's try to see. Basically, these are all remedial measures to achieve the reliability. Say, for example, in our data set, we are having statement 1, 2, 3, 4, and participant 1, 2, and 3. Unengaged respondent is who is doing the extreme ticks like this. Either he ticks all 5 or all 1. Now, what will happen that when you are having such type of participant in your data, and if you calculate the standard deviation of it, you will get 0. So variance extracted, you can imagine it turns out to be just 0, and therefore this is an unengaged respondent. Equally, it can also happen that you have asked such a statement in which there are all extreme ticks which we are getting. Everybody ticks on 5. This also is not advisable, or rather, this is not we cannot appreciate such data. Or we are having such data in which two statements are strongly correlated with each other, S2 and S4. In such scenario also, we can face this problem where the reliability is not achieved. The third problem is that there is an outlier in your data. Somebody has entered 10. So there is an extreme observation in your data. In such scenario also, we will not be able to get the reliability. Now we will have to check the divergent validity. Means how closely items of different construct are closely related with each other. We have already discussed this is desirable, this is desirable. The relationship between statements S and statement 3, that is a high correlation between statement S and T, is not desirable. Okay. So let us try to run the validity in SmartPLS. So this is our model which we have drawn. I will again go and calculate PLS-SEM algorithm, start the calculation, open the report, and I'll click on discriminant validity. Now, how to interpret this? Let us see. First of all, I'll click on Fornell-Larcker Criterion. Here, Fornell-Larcker Criterion. Now, there is some relationship between Fornell-Larcker Criterion and average variance extracted, which is there in construct reliability and validity. So just see for co-workers. I'll go in construct reliability and validity, and for co-workers. Now, if you take the square root of 0.758, you will get the figure which is this one, 0.871. Similarly, if I go in environmental perception, and if I take the square root of this, I'll get the figure, this figure I'll get. Now I'll copy this result to Excel, or rather I'll take the screenshot of this. Now, how to interpret this result? Let's see. In case of Fornell-Larcker criterion, it is necessary that diagonally these values they should be maximum for the corresponding rows and columns. So if I talk about environmental perception, this value should be highest in corresponding column and corresponding rows. If it is highest, we have achieved the discriminant validity. Now, what are these other numbers? These numbers are correlation of job satisfaction construct with the co-worker construct. So these are all correlations. So this is a way you should interpret. If you get the highest figure, then you have achieved the discriminant validity. Again, I'll go in SmartPLS. You can also get the cross loadings from here. At any moment of time, if you feel that any of your statement is showing the cross loading, see at present AC1, AC2, AC3, AC4, it is having a good correlation with the construct co-workers and less correlation with the other construct. But cross loadings will happen when one statement is showing cross loading on two other constructs. At that moment of time, you will have to take the decision that this statement should be loaded on this particular construct or another construct. Now, there is a limitation of this Fornell-Larcker criterion. It is used in combination with results of variance-based structural equation modeling, such as traditional partial least square path modeling and generalized structured component analysis. The Fornell-Larcker criterion lacks sensitivity, and therefore a biasness was observed in Fornell-Larcker criterion. To remove this biasness, Hensler, Ringel, and Starstad introduced a new statistics, which is Heterotrait-Monotrait Ratio of correlation for assessing the discriminant validity. So the HTMT is a measure of similarity between the latent variables. If HTMT is clearly smaller than 1, discriminant validity can be regarded as established. Now let us see. We will go in heterotrait-monotrait, and you can see all of them are less than 0.85, and therefore discriminant validity is achieved. The same thing I can confirm from here also. You can see all of them are less than 0.85, a threshold limit. Now we will take one case study, which is already loaded in your SmartPLS. That is ECSC data. I will activate it. I'll run PLS-SEM algorithm, start the calculation, and open the report. Now I will see the discriminant validity of this. Now you can see here, first of all, in case of Fornell-Larcker criterion, let us take this result. Let us take the screenshot of it. How to understand this result? Let us see. We'll have to see diagonally, first of all. Are the values maximum diagonally? So you can see here there is a dispute which is there in image, and yeah, there is a dispute in image, first dispute, and possibly here also in per Q. So the Fornell-Larcker criterion is giving the hint that there is a problem of discriminant validity. Now let us check the same thing in Heterotrait-Monotrait ratio. Yeah, you can see here that Kusal and CUSA, Kusa, image and Kusa, Perk and Kusa, they all are having the values which are more than 0.85. This means that the statements are getting over, there are some cross loadings which are happening. It means that there are some statements in Kusal. So when the respondents are filling up this questionnaire, the statements of Kusal are having a strong correlation with Kusa A. Let us check this cross loadings and try to see is it happening. So Kusa So click on Heterotrait, image and Kusa. So let me take the image and Kusa. So you can see here the statements are getting cross loading. Here also it is showing the relationship, and here also image. So here they are having some high correlation, and therefore the cross loadings are seen here. So the only thing which you can do is you will have to refine the statement so that cross loadings can be avoided. So that's all about reliability and validity testing. Basically, the testing of the measurement model in SmartPLS-4. Please subscribe to my channel. Don't forget to press the like button. You can also follow me on LinkedIn and Twitter. You can also refer my playlist in which I have already uploaded many videos which are related to SmartPLS-4. Thank you.